Welcome to IbPython3, a native Python 3 implementation of the Interactive Broker's API software version 9.70. I've assembled a series of IPython notebooks to demonstrate the features of the API and to illustrate the relative ease of interacting with the IB server from Python Interactive Console window. Let's get started with a brief introduction. The IB connector module is the only module required to establish a connection with the server, but other modules may be needed depending on the examples that you use. Let's run that cell. When establishing a connection, we have to specify the connection type as either TWS for the Trader Workstation or IBG for the IB Gateway software. One of the benefits of IPython is its tab completion. Pressing tab at the start of a function provides all the parameters, full parameter list for that function. Or if you hit tab twice, it gives you the doc string or the full help for that function. It's obviously a very useful time-saving feature. Let's run this cell to establish our connection. Now, because of the asynchronous communication between the server and the client, messages will sometimes accumulate. In order to view those messages, you can just hit enter into an empty cell to view everything that has been received so far. Here are some warning messages which are quite common for the data connections. Now let's do a simple hello world example where we request the time from the server just to ensure that our connection is working. This simple example takes the request, prints out the Unix timestamp, and then it prints out the timestamp formatted for the local time zone. This simple example accesses IbPython's IB container class, which is an IB container object, and it retrieves the values sent back from the server. These custom-built thread-safe containers are what makes IbPython's implementation of the API unique, and also play into the power of Python and its built-in list and dictionary data structures. We'll discuss these containers and how to use them in a later video. Let's run this cell, and sure enough, we show our current time, the timestamp that's actually returned from the server, and then the formatted timestamp here. Let's use these containers to temporarily store and retrieve contract details returned from a request. In this example, we're looking at SPY, or spiders, the S&P 500 Exchange Traded Funds, or ETF, contracts. Here is a contract ID number, which we found by going to this link and specifying the contract until we found the contract to identify the contract ID. And we are requesting the contract directly using this contract ID number and making our request to the server. Now, that information has already been returned, and this is what picks it up. This will use the containers, get the item out of the container, and then show the results. Here are the contract details that have been returned from the server for this client, for this contract. SPY, as we said, which is a spider S&P 500 ETF trust. And this is the summary of that contract. Now here we have a simple plot function, which we're going to make use of in our examples below. We will request some historical data, and we'll use this plot function to plot this data. There is a function getUID, which is a unique identifier. This is connected to the client so that we can always obtain unique identifier numbers quite easily to track our requests. Now here we're going to look at the timestamp right now, and we'll look at 1 year of historical data and make that request from the server and retrieve the bars that have been returned. Then we'll plot that data. And this is the data that has just been returned from the server. We also included an exponential moving average of 45 days on that data as well. We can make use of simple custom functions to do lots of things. In this example, we'll have a function which simply gets a chart based on the contract ID and what we want it to show. The default value will be the closing price, but we could also specify the bid, for example. So in this case, we'll look at the prices for Apple, the Eurodollar, and for Google. These prices have been instantly returned from the server. Apple share price, the Eurodollar rate, and Google. Note the drop. There was a 2-for-1 share split that occurred at the start of April for Google. This is one of the issues when using historical data in TWS. Sometimes they're not back adjusted depending on the contract itself. So always be a little cautious with the historical data that you receive. Now let's print the bars that we returned. We'll use the list comprehension that Python's list comprehension to list all the bars that were returned for Apple and print those out. This is the full 1-year price series going back 2013 April all the way up to 2014 April. So 1-year full series of the price data. Now, based on those bars, we can easily filter them for criteria such as a date range or prices. Let's look at all bars where the closing price was between 500 and 505, which is a subset of the original data. So that's pretty much it for our introductory demonstration of IbPython3. When you're finished, remember to disconnect, and at a later time, it's easy to reconnect using the same client and disconnect again. Thank you very much. Look forward to future videos.